anesthesia machine. It was year 1914 where Guatme designed a box to deliver gases which was known as Guatme's box. So let us learn a little bit about the evolution of anesthesia machine. Evolution of anesthesia machine. It was the year 1914. It was the year 1914. The person called Guatme, he designed a box. He designed a simple box. He designed a box to supply gases. This was known as Guatme's box. Okay. From there, moving on to year 1917, a person called Edmund Gaskin Boyles. A person called Edmund Gaskin Boyle. This person designed the Boyle's apparatus. He designed Boyle's apparatus. The specialty between Guatme and Boyle's machine is that Boyle's machine delivered continuous flow of gases. To deliver continuous flow of gases. Especially he made this machine to deliver oxygen. On the left of this slide you can see the Boyle's machine. Even today we are using Boyle's machine in many OTs. In most of the places where rural areas where there are not advanced techniques are available, there we are still using the regular Boyle's machine. Alright, then what is the situation now in 2023? Now we are using something called the very modern anesthesia workstation. The workstation does most of the work for the anesthesiologist. Anesthesia workstation. This workstation integrates many components. This workstation integrates many components which are necessary for administration of anesthesia. Many components necessary for administration of anesthesia. Administration of anesthesia. Into a single unit. Into one unit. So what do you mean by many components? This workstation which you can see on the right side of the slide, here you can see the vaporizers, you can see the flow meters, an auxiliary oxygen meter. There is a monitor to show the ventilator settings or the data management system. The safety alarms can also be seen over there. Okay, then you have many drawers for keeping the anesthesia equipment for the emergency airway cart. Then you have the soda alarm canister. Then you have a ventilator. Then you have a breathing circuit. Alright, so this workstation provides multiple components into a single unit to deliver the anesthesia. So this is a modern anesthesia machine, and today we are in this stage. And from 1914 to into 2023, what has changed? As this system has followed, there are two main important things which are worth telling about. The first thing is there is improved safety. Alright, there is improved safety from the regular Boyle's machine to workstation. There is improved safety. And the second thing is there is decreased anesthetic related risk to the patient. There is decreased anesthetic related risk. To the patient. Many safety features have been added and there are many alarms. Okay, all these are safety features which definitely will reduce the anesthetic related complications to the patient. Alright, now moving on. Now that we have learned about the evolution of the anesthesia machine, let us know about the components of anesthesia machine. So what are the two components of anesthesia machine? Any anesthesia machine will have two major types of components. One is electrical components and the other one is pneumatic components. So what do you mean by the word electrical components? In the electric components, it includes a master switch, then there is a power failure indicator, then there is reserve power, then there are electrical outlets, alright. Then we have the circuit breakers, we'll know briefly about each of them, but before that we'll know what are the pneumatic components. In the pneumatic components, then again it is divided into three types: the high pressure system, then there is intermediate pressure system, and then there is low pressure system. Alright, now moving on, let's know briefly about 1 to 2 points about each electrical component. So in electrical components, the first thing we have is the master switch. There is a single master switch which activates both pneumatic as well as electrical components. Alright, the master switch activates both pneumatic and electrical components of the machine. Now moving on, the second thing we have seen is a power failure indicator. The power failure indicator can be visual or auditory indicators. Visual or audible indicators. This will alert you when the power is lost. Okay, this will alert you when power is lost. Done. Now moving on, we have reserve power. Reserve power, it is nothing but a backup source. Okay, a backup source of power. Reserve power is a backup source of power. Whenever occasionally when you're out of power, then definitely the reserve power will be a good backup source. So the fourth thing is electrical outlets. These electrical outlets are intended to power the anesthesia monitors. They are intended to power anesthesia monitors. The other machines like the ultrasound machine or any other machine or any other appliances, they have to be connected directly to the main power source and not to the anesthesia machine. Okay, this is not for other appliances. Alright, then we have something called circuit breakers. These circuit breakers, they are activated when the load is very high, okay, they are activated. When load is very high, and this will eventually prevent the damage of the machine. When load is high and prevents damage of the machine. Alright, I hope this is clear. Then moving on, we have something called pneumatic component. And this is very important. This is where you have to concentrate. Pneumatic components. There are many MCQs from this sector of this lecture, so listen carefully. The pneumatic components, alright, as I said before, there are three types: the high pressure, then comes the intermediate pressure, and there is something called low pressure. So based on what pressure it is divided. If you take oxygen as a gas, then in high pressure system the pressure of oxygen is 2000 psi, pounds per square inch. Then in the intermediate pressure system it is about 55 to 60 psi. Alright. Then in the low pressure system it is about 15 to 20 psi. Alright. So what are the components which come under the high pressure system? This is very important. They are hanger yoke assembly, high pressure system, intermediate pressure system, and the low pressure system. The hanger yoke assembly, then comes the cylinders, then the cylinder pressure gauge, cylinder pressure gauge, then the first stage pressure regulator, Is this clear? Then we have the intermediate pressure system. In the intermediate pressure system we have pipeline inlet connections. Alright. Then we have gas power outlet. Alright. Then we have the pipelines. Then there is the oxygen failure safe valve. Okay. Then there is the oxygen pressure failure alarm. Pressure failure alarm. Then there is oxygen flush. Okay, this is clear. Then we also have the second stage pressure regulator. Then we have something called flow control valves. They are also included in the intermediate pressure system. Flow control valves. Then what comes under the low pressure system? The important components in the low pressure system are the flow meters. Then comes your vaporizers. Okay. Then there are hypoxia prevention devices. Then there are unidirectional check valves. Okay. Then there are pressure relief devices. Then there is a common gas outlet, CGO. Okay, let's dissect the anatomy of the anesthesia machine. Okay, so consider that this is the air cylinder. Okay, now we have the nitrous oxide cylinder, then we have the oxygen cylinder. Alright, then I'm making a small line over here, a small line over here. This line represents the air. Then let's make a nitrous oxide line. Alright, then let's make an oxygen line. Simple, this is very clear. This is an easily representing line diagram for knowing the high, intermediate and low pressure systems, so listen carefully. So this is the air cylinder, nitrous oxide cylinder and oxygen cylinder. Then here we have something called as a check valve. Assume that this is a check valve. There is a check valve for all the gases. This check valve will prevent the backflow of the gases, and it will make sure that the gases are flowing unidirectionally only from the cylinder to the anesthesia machine. So what is this? This is a check valve. Simple. Then there is a pressure gauge. There is a pressure gauge for all the gases. Understood? Now we have something called as a primary pressure regulator. There is a primary pressure regulator. So this is a primary pressure regulator. Primary pressure regulator. This is a pressure gauge. This is a pressure gauge. I hope it is clear till now. Then as we go further, we will meet our friend who is the pipeline. We will meet our friend who is the pipeline. So there is a pipeline for each and every gas. So there is a pipeline for all the gases. Clear? The pipeline is connected. The pipeline is connected. The pipeline is now connected. Done. Now here also there is a check valve. Even in the pipeline there is a check valve. There is a check valve for all the three gases. Okay. Then there are pressure gauge over here also. Even at the pipeline there are pressure gauges. Simple. There is a check valve, there is a pressure gauge, and there is a first stage pressure regulator. And similarly to the pipeline also, there is a check valve, there is a pressure gauge. There is a check valve, there is a pressure gauge. Understood? Now we can move further. Then we have a pressure relief valve. Then we have a pressure relief valve. We have come from high pressure to intermediate pressure system. So there is a pressure relief valve for all the gases. There is a pressure relief valve for all the gases. You remember the parts still here. Then moving on, when you come to the oxygen supply, here you have an attachment of the power outlet. There is an attachment of power outlet. Alright. Then there is an attachment for oxygen flush. There is an attachment for oxygen flush. Then there is a master switch. Then there is a master switch. Alright. Then there is an oxygen pressure alarm. There is an oxygen pressure alarm. Okay. So in the oxygen there is a power outlet, there is oxygen flush, there is a master switch and an oxygen failure alarm. All these are interconnected. Alright. Then we have something called a oxygen failure safety device. Oxygen failure safety device. So here the oxygen is connected to the nitrous oxide supply. Then this is also connected to the air supply. Okay, simple line diagram. So this is the oxygen failure safety device. oxygen failure safety device. I hope this is very clear. Moving on, now we have the second stage pressure regulator or secondary pressure regulator. Secondary pressure regulator. There is a secondary pressure regulator. Similarly, for oxygen also there is a secondary pressure regulator. It is similarly for all the three gases, it is the same. Then moving on further, we have something called a flow control valve. There is again a flow control valve for all the three gases. Simple. Now moving on, we have something called flow meters. We have flow meters. There is a different flow meter for every gas. So there is a flow meter for air, there is a flow meter for nitrous oxide, there is a flow meter for oxygen. Clear? Now air goes into the flow meter of air. Similarly, nitrous oxide goes into the flow meter of nitrous oxide, and oxygen goes into the flow meter of oxygen. I hope this is clear. From here, all the three gases will pass through a device which is known as vaporizer. Now here we have a vaporizer. So this is a vaporizer. These are the flow meters. I hope this is clear. From the vaporizers, all these gases are going to come down. All these gases are going to come down to something called the common gas outlet, or the CGO or the common gas outlet. Okay. Just remember that there is a pressure relief valve. There is a pressure relief valve over here also. Pressure relief valve. There is a pressure relief valve before the common gas outlet also. Alright. Remember one thing. From the oxygen supply, there is also an auxiliary supply. From the oxygen pipeline, there is also an auxiliary supply. There is also an auxiliary supply to something called as auxiliary flow meter. Something called as auxiliary oxygen flow meter. And one more thing you have to remember over here is that the oxygen flush is directly connected to the common gas outlet. The oxygen flush button is directly connected to the common gas outlet. I hope this is clear till now. This is a simple line diagram. So air, nitrous oxide and oxygen. Then there are check valves. There is a pressure gauge. There is a primary pressure regulator which is similar for all the gases. Then there is a pipeline connection. This is the pipeline for all the gases. Then there is also a check valve and pressure gauge for all the pipelines also. Alright. Then we have something called as a pressure relief valve. Pressure relief valve. There is a pressure relief valve for each gas. Then we have power outlet, oxygen flush, master switch and oxygen failure alarm for the oxygen. Then oxygen is connected with all other gases. Okay, there is oxygen failure safety device for nitrous oxide. Then further on moving on, we have secondary pressure regulators. Clear? Then we have something called flow control valves. These are the flow control valves. Then we have flow meters. All these gases will go to the flow meters. Okay, where the flows can be set. And from the flow meters, the gases are again passed through the vaporizers. And in the vaporizers, when the inhalational agent is added, all the gases go through a pressure relief valve, and which will finally end up in the common gas outlet. Is this clear? Now to clearly demarcate between these, if I draw a line before the pipeline, If I draw a line like this, then this will make your high pressure system. This is nothing but your high pressure system. Clear? Now if I draw a line before the flow meters, then this part is nothing but your high pressure system. This part is nothing but your low pressure system. Now whatever is left in between, all this will come under your intermediate pressure system. I hope this is clear. This is a simple line diagram. If you remember this diagram, it is easy to write even a 10 marks essay answer or any answer, and it is easy to answer many questions. I want you to repeatedly watch this video, especially this part of the video, multiple times so that you can grasp all the information in this. Alright, so let's move on. Alright, now let us know about each component in detail. High pressure system. Dealing about high pressure system, the first one we are going to deal is about the gas cylinders. Multiple questions, multiple MCQs have been asked in this topic called gas cylinders about the color coding and pin index safety system. So it is very important. Just focus on the topic. So in the gas cylinders, the first thing we have to know is that they are made up of an alloy of steel and molybdenum. They have a 3AA marking. This alloy will give it a tensile strength. And it will also reduce the weight of the cylinder and decreases the weight of the cylinder. Okay. Then we have something called MRI compatible cylinders. These cylinders are not fit for an MRI, magnetic resonance imaging. So for an MRI, there are specialized cylinders which are made of aluminium. There are MRI compatible cylinders. And these cylinders are made up of aluminium or sometimes titanium, but you know titanium is very costly, so we'll use only aluminium cylinders. And these cylinders are marketed by 3ALM marking. Okay, so why are these MRI compatible cylinders if it is made up of aluminium? Because they are non-ferromagnetic materials. Clear? Now in what sizes are these cylinders available? Sizes of the cylinders. In the increasing order of size, the cylinders are from AA to H. AA is small size and H is large size. And the size attached to the anesthesia machine, the cylinder size which is attached to anesthesia machine is E-type. The size is E-type cylinder. And for example, if it is oxygen cylinder, the E-type cylinder size is about 660 liters. The size of E-type cylinder of oxygen is 660 liters. Alright. So let us know what are the parts of a cylinder. There are mainly three parts. One is a valve, then we have the shoulder, and there is body of the cylinder. In this image you can see this is the body. Here you have the body of the cylinder, then you have the shoulder, and this is called as the valve of the cylinder. Simple. Now before we go into the detail of the color coding of the cylinder, let us know what is known as the critical temperature. The critical temperature is the temperature at and above which a gas cannot be converted into a liquid. A gas cannot be converted into a liquid. The temperature at and above which a gas cannot be liquefied. A gas cannot be liquefied no matter how much pressure you apply to it. No matter how much pressure is applied. This temperature is known as critical temperature. And for oxygen, the critical temperature is minus 118.6 degrees centigrade, minus 118.6 degrees centigrade, or it is minus 181 degrees Fahrenheit. Alright, and for nitrous oxide, it is 36.4 degrees centigrade. Alright, now you know why nitrous oxide cylinder has a liquid and oxygen cylinder has a gas. So that is the significance of the critical temperature. Now what is a liquefied compressed gas? What are the examples of liquefied compressed gases? That is the gases which are stored as liquids in the cylinder. One example I have already told you, which is nitrous oxide. The other gas is carbon dioxide. Even carbon dioxide is stored as a liquid in the cylinder. Then what are the other gases other than oxygen which are non-liquefied gases? Oxygen, nitrogen, air, and then we have helium. All these are non-liquefied compressed gases. Non-liquefied compressed gases. Alright. Now you just have to know that 1 atmosphere is 14.7 pounds per square inch, which is equal to 760 mm of Hg. Sometimes there can be questions on Boyle's law and all in even NEET PG or INICET examination. So if you know this basic equation, you can solve some problems based on Boyle's machine or Boyle's law for anesthesia or gas cylinders. Alright. Now moving on, let us know what is service pressure. Let us know what is service pressure. The service pressure is a pressure which is a maximum pressure to which a cylinder can be filled. Okay, it is the maximum pressure. It is the maximum pressure to which a cylinder may be filled. To which a cylinder may be filled at 70 degrees Fahrenheit. At 70 degrees Fahrenheit. And this service pressure, it is applicable only for the gases, cylinders which have gas and not liquids. So this is not applicable for liquefiable gases. This service pressure is not applicable for liquefiable gases. What are the examples of liquefiable gases? Nitrous oxide, then carbon dioxide. So nitrous oxide cylinder, there is a special entity by which it is filled. This is known as filling ratio, or it is also known as filling density. What is filling ratio? It is the ratio of weight of the gas in the cylinder, weight of gas in the cylinder, divided by weight of water that cylinder would hold. Weight of water that the cylinder would hold. That the cylinder would hold at the same temperature. Would hold at 60 degrees Fahrenheit. At 60 degrees Fahrenheit. And for nitrous oxide, the filling ratio is 68%. The filling ratio is 68%. Is this clear? Now there is a very important point over here which could be asked in your examination. If a cylinder is containing nitrous oxide, here in this picture you can see when the nitrous oxide cylinder is full, then the pressure gauge is showing that the cylinder is full. Then half of the liquid is over, half of the liquid is consumed, still the pressure gauge is showing full. Then 3/4 is completed, then also it is showing full. So until and unless more than 3/4 of the liquid in the cylinder is consumed, the pressure gauge does not show that the cylinder is empty. This is due to this property which I have just stated, which is the filling ratio. Alright. So a cylinder containing any liquefied gas, for example nitrous oxide, the pressure will remain constant. The pressure will remain more or less constant till there is any liquid in the cylinder. Once this liquid component is completed and there is only gas, then there will be a fall. There will be a fall in the pressure in the pressure gauge, as long as there is liquid in the cylinder. Alright, this is very important. So until and unless there is liquid remaining in the cylinder, the pressure gauge will not show that the cylinder is empty. Okay, this is a drawback on nitrous oxide cylinders. Then moving on, we have valves. We have spindle valves. These spindle valves are attached to the neck of the cylinder. They are attached to the neck of the cylinders. They are made up of bronze. They are made of bronze or brass, and they are of two types. They can be packet type or they can be diaphragm type. And the packet type of the valves are most common. Then we have cylinder handle. The handle is also known as hand wheel, or it is also known as cylinder wrench. This picture you can see, this is the hand wheel. It is used to open or close the cylinder. Alright. Use it to open or close a cylinder valve. So here you can see the valve is being opened using a wrench. So to open or close, what is the direction of the wrench? This is important. If you want to open a cylinder, then the counterclockwise direction rotation is required. Counterclockwise direction. And opposite, if you want to close the cylinder, then clockwise rotation is required. Then we also have a pressure relief device. Pressure relief device. We have valves, we have cylinder handle, we have a pressure relief device. The pressure relief device is used to vent out the gases. If the pressures are too high, they will help in venting out the excess gases. Venting out the gases if pressure is dangerously high. The pressure relief device, it is also known as a fusible plug. It is also known as a fusible plug, or it is also known as a rupture disc. These are the types of pressure relief devices available. It could be a fusible plug, it could be a rupture disc, or it could be a pressure relief valve, or it could be a pressure relief valve, or it could be a combination of all these three, or it could be a combination of all these three. Alright, I hope this is clear. Now we'll move on to a very important concept about the cylinders. This question has been frequently asked in the exams. So the first cylinder you are able to look at here, you need to identify the cylinder based on the color coding of the cylinder, the body and the shoulder. Alright, here you can see a cylinder which has got a grey body, the cylinder with a grey body, and there are white and black shoulders, white and black quarters. So this is a cylinder of air. This is a air cylinder. Now we have a cylinder with black body and white shoulder. Black body and white shoulder. So this is a oxygen cylinder. This was a previous year question. Alright. Now we have a completely blue cylinder. A cylinder with body and shoulder both are blue in color. So this is a nitrous oxide cylinder. This is also a previous year question, very frequently asked. Next, look at this cylinder. It has a blue body and it has white and blue quarters. So this is a cylinder of something called NExT. NExT is a mixture of nitrous oxide and oxygen. Alright. These four cylinders are the most important cylinders for color coding for your examination purpose. Let us know other cylinders also, just identify these cylinders. So you can see a grey cylinder, a completely grey cylinder. This is a carbon dioxide cylinder. Then here you can see an orange cylinder. The gas is cyclopropane. Alright. Then here you can see a brown cylinder. The gas is helium. Then here you can see a black cylinder. The gas is nitrogen. Okay. Then moving on, let's move on to a very important topic, which is the PISS, the pin index safety system. One more very important topic for your examination. Pin index safety system. So why do we need pin index safety system? It is a safety mechanism. Pin index safety system is a safety mechanism. It prevents the wrong attachment of the cylinder to the anesthesia machine. Attachment of a wrong cylinder to the anesthesia machine. Prevents attachment of wrong cylinder to the machine. Okay, in the pin index system we have pins. Alright, we have pins and we have holes. Now where are these pins located? The pins are located on the machine. In this diagram you can see these are the pins. The pins are located on the machine. Then we have holes. The holes are located on the cylinder. These are located on the machine. These pins are 4 mm in diameter, except for 7. The pin 7 is thicker. The pin 7 is more thicker than other pins, and they are 6 mm in length. There are 6 millimeters in length. Alright. Now where are these holes located on the cylinder? The position of holes on the cylinder, they are located on the circumference of a circle. They are located on a circumference of a circle. A 9 by 16 inch radius circle, which is located at the center of the port. Alright. So the holes position and the pins position will differ for every cylinder. It will differ with the gas, and that's what is the safety mechanism, how it will prevent the wrong attachment of the cylinder. Is this clear? Alright. For example, if this is the arc of the circle, then there is 1, 2, 3, 4, 5, 6. This is the numbering, and in the center there is 7. Unless these pins and holes are aligned, and the port will not be seated. Correctly. Okay, one cylinder won't be fitted into the holes of the other gas. Alright. So most importantly, we have to know the pin index number of each gas. This question was frequently asked in your exam. So it is easy to remember the pin index if you focus carefully. I'll tell you an order in which the pin index can be remembered. So firstly, we have air. For air, the pin index is 1,5. Then we have oxygen. For oxygen, it is 2,5. Then for nitrous oxide, it is 3,5. Clear? Simple. Then we have oxygen and carbon dioxide. With carbon dioxide concentration more than 7.5%. Carbon dioxide more than 7.5%. The pin index is 1,6. Simple. Then oxygen and carbon dioxide with carbon dioxide less than 7.5%. The pin index is 2,6. 1,6 followed by 2,6. Then we have cyclopropane. The pin index is 3,6. Clear? Then we have heliox with helium more than 80%. Then we have heliox. The pin index is 4,6. So 1,6, 2,6, 3,6 and 4,6. Simple. Okay. Then we have entonox. As I told you, it is a mixture of oxygen and nitrous oxide. Oxygen plus nitrous oxide. The pin index of entonox is 7. The number of letters in entonox is also 7. So easy to remember. Then if you come this side, for nitrogen, the pin index is 1,4. Okay. Then for heliox with helium less than 80%, it is 2,4. So 1,4 followed by 2,4. 1,4 followed by 2,4. Then 1,4, write it before 1,5. Then 2,4, write it before 2,5. Okay. Or still more easy way to remember. In air you have AIR. I looks like 1, so 1,5. Then oxygen has 2 atoms, so 2,5. Nitrous oxide has 3 atoms, so 3,5. Simple to remember. Entonox has 7 letters, so the pin index is 7. I hope you got it. So revise the pin index system multiple times because there is a question every year on the pin index system. Here in this picture you can see this is the pin index of oxygen. The cylinder is oxygen, black body, white shoulder. The pin index is oxygen, which is 2,5. Then this is a blue cylinder, which is nitrous oxide cylinder. The pin index is 3,5. The pin index is 3,5. Simple. Now moving on, we have the cylinder. Pressures. You need to know the cylinder pressure of 2 gases. One is oxygen. The pressure of the cylinder is 2000 psi. and I have already told you the size, which is 660 liters. Now we have nitrous oxide cylinder. The pressure inside the cylinder is 760 psi. Got it? Now we have something called as a Bodox seal. We have something called as Bodox seal. Bodox seal. Okay. So here you can see this is called as a hanger yoke assembly. Hanger yoke assembly. So what is a Bodox seal? The hanger yoke assembly has a nipple, a Bodox seal, or a washer, or a neoprene seal. Okay. It is called as a neoprene seal or a washer. Alright. This neoprene seal you can see in this picture. In the first picture you can see that there is a washer. There is a washer which will be present between the cylinder and the yoke. In the second picture you won't see any washer. So what is the purpose of this Bodox seal? The Bodox seal will prevent any gas leakage by giving a tight attachment between the cylinder and the yoke. It will prevent any gas leakage by keeping the cylinder as well as the yoke in good attachment. It will create a very good seal. It is used for creating a good seal. For creating a good seal. And it prevents any gas leakage. Prevents any gas leakage. Gas leakage between what? Between the cylinder and the machine. Between the cylinder as well as machine. But the problem is when you put more than one washer, or you won't put any washer, then there is a chance of piss being voided. That is, the pin index system, the safety mechanism is lost. When you use more than one washer, the safety mechanism of pin index system is voided. It is lost. Alright. Then what are the other components? Other small components are, there is labeling on the cylinder. There is labeling. There are other markings like the testing info. When was the cylinder tested? What was the service pressure and all? The testing info and the tags. All these are present, clearly mentioned on your cylinder. Similarly, as like your LPG cylinder, you can find all the markings on the cylinder about the gas, about the service pressure, about the testing info and all. Clear? Now, what are the other oxygen sources other than the oxygen cylinders in a hospital? Other oxygen sources in hospitals. The first source I want to talk about is the liquid oxygen tank. A liquid oxygen tank. Outside your hospital, like most of the tertiary care centers also, they have planted a liquid oxygen after the COVID pandemic. So what does this liquid oxygen tank have? It has a vacuum insulated evaporator. Remember this word, vacuum insulated evaporator. Vacuum insulated evaporator, or VIE. Here you can see the liquid oxygen tank. This is the liquid oxygen tank. It has a vacuum, and here is the liquid oxygen. Alright. So what is the capacity? The capacity of a liquid oxygen tank is 1500 liters. 1500 liters of liquid. 1500 liters of liquid. And how much is the temperature inside a liquid oxygen tank? The temperature is about minus 160 degrees centigrade. Why minus 160 degrees centigrade? Because it has to be less than critical temperature of oxygen. Because if it is at the critical temperature of oxygen, again any gas cannot be converted into a liquid, so it has to be less than critical temperature. So So it will be minus 160 degrees centigrade. And how much is the pressure? How much is the pressure? It is 5 to 10 atmospheres. The pressure is 5 to 10 atmospheres. The second thing is oxygen concentrators. During the COVID time, we have seen many people buying oxygen concentrators and putting it at home, putting a mask. Okay, oxygen concentrators. What is this principle of oxygen concentrator? It uses a special technology which is known as pressure swing absorption technology. Pressure swing absorption technology. Absorption technology. What is that adsorbent which is purifying the air? Adsorbent. What is the adsorbent material which is used? It is called zeolite. The adsorbent material is zeolite. And what does the zeolite do? Oxygen is not absorbed by the zeolite and it will allow it to pass freely and stores. Oxygen is freely passed through this material. Oxygen is freely passed while the other gases are absorbed. Oxygen is freely passed through this material. Done? Are we clear till now? Then let us move on to intermediate pressure system. Intermediate pressure system. We have already seen the components of intermediate pressure system. So we have pipelines. The color coding of pipelines is also asked frequently in your examination. So let us learn them. Pipeline. The pressure in the pipelines is 55 to 60 psi, pounds per square inch, as you know. Then what is the color coding? You can clearly see in this picture the color coding for the nitrous oxide is blue, for oxygen is white, and this black pipeline here is for air. Okay, in this picture also you can see nitrous oxide, oxygen pipeline. Is that clear? So let us write down: white oxygen, black is for air, blue is for nitrous oxide. This question was asked previously. And yellow is for vacuum. You can find yellow color pipelines all over in your hospital. Oxygen, white color, yellow color vacuum, and nitrous oxide blue. Clear? Then for pipelines we have something called the diameter index safety system. Diameter index safety system. Similar to the pin index safety system, the diameter index safety system will also prevent the incorrect attachment of the pipeline. Prevents incorrect attachment of pipeline to anesthesia machine. Incorrect attachment of pipeline to anesthesia machine. So this is also a safety mechanism. Is this clear? Oxygen failure safety device. Oxygen failure safety device. This is a safety mechanism to prevent hypoxia. So whenever the oxygen pressure falls below a manufacturer specified oxygen concentration, then the minimum oxygen concentration is maintained. For example, about 19% of the oxygen concentration will be maintained at the common gas outlet when the pressure falls below the manufacturer specified minimum. Okay, when oxygen pressure is reduced below a manufacturer specified minimum, below below a manufacturer specified minimum, the delivered oxygen concentration will not fall below 19%. The oxygen concentration shall not fall or decrease below 19% at the common gas outlet. This is known as oxygen failure safety device. Then we have something called oxygen failure safety valve. Oxygen failure safety valve. What does this oxygen failure safety valve do? It interrupts the supply of nitrous oxide if there is a supply failure or decrease in the pressure of oxygen. Then this oxygen failure safety valve will interrupt the supply of nitrous oxide. So this valve will interrupt the supply of nitrous oxide, the supply of N2O, if oxygen supply decreases, if oxygen supply pressure decreases. Clear? Then we have something called oxygen supply failure alarm. Oxygen supply failure alarm. And when is this oxygen supply failure alarm activated? When the oxygen pressure falls below a certain pressure. When oxygen pressure is less than 30 psig within 5 seconds. At this pressure or below this pressure, the activation of oxygen pressure failure alarm will take place. Clear? Then we also have something called a second stage pressure regulator. This pressure regulator reduces the oxygen pressure to 14 pounds per square inch, 14 psig, and for nitrous oxide it will reduce to 26 psi. Hope I am clear. Till now we have discussed all the components of the intermediate pressure system. Now we are going to discuss a very important other component, which is oxygen flush. Question can be asked on oxygen flush also. So this is also a very important topic. Oxygen flush. Oxygen flush is also a safety mechanism. It acts as an emergency oxygen source. Emergency oxygen bypass. It is labeled as O2 plus. You can see in this picture. Okay, that is the oxygen flush button. Even if the master switch is on or off, irrespective of the on of the anesthesia machine, the oxygen flush can be activated. Oxygen flush can be activated whether master switch is on or off. Whether master switch is on or off. Clear? Then how much is the flow when master switch is activated? How much is the flow? It is about 35 to 75 liter per minute. This can be a question. This is important. The flow can be 35 to 75 liters of oxygen per minute. Then what is the pressure? The pressure is, again, since it comes under intermediate pressure system, the pressure is 55 to 60 psi. You can also see that there is a silver color lining or there is a protective ring, so that the emergency oxygen source won't get touched and activated. So there is a ring or a protective ring to prevent accidental activation. Clear? Now the final component of the intermediate pressure system is the flow control valves. We have flow control valves. Flow control valves. Here in this picture you can see the flow control valves. The flow control valve of nitrous oxide, air and oxygen. You can see that the oxygen flow control valve is quite different from the nitrous oxide and air valves. Okay, and you can see the name of the gas mentioned on each flow control valve with their individual color coding already there. All these are safety mechanisms. And also the flow control valves, the flow control valves of oxygen are fluted. It is larger and fluted than the other gases. This is also a safety mechanism. Even when there is a power cut in the OT and you can't see anything, by just palpating the flow control valves, you can identify whether you are switching on or off an oxygen flow meter or a nitrous oxide flow meter. So this is very important. Next, moving on, the last element in the anesthesia machine lecture, we'll talk about low pressure system. We'll talk about the low pressure system. Alright. The first thing we are going to talk about is the flow meters. Flow meters. What are flow meters? They are nothing but glass tubes. Here you can see these are the flow meters. They indicate the rate of flow of the gases. They indicate a rate of the flow of the gases which are passing through those flow meters. Indicate a rate of flow of gases passing through them. Gases passing through them. Previously there used to be mechanical flow meters. Even nowadays we use mechanical flow meters only, but when in advanced setups there are electrical flow meters also. Mechanical, in this picture you are able to see the mechanical flow meters, and there are also electronical flow meters available, digital flow meters, electronic flow meters. Clear? So here you can see that they are nothing but vertical glass tubes. Vertical glass tubes. They are also known as Dorsch tubes. Dorsch tubes. Alright. And these tubes are variable orifice tubes. Variable orifice. What do you mean by variable orifice? At the bottom the diameter is less, and as we go upwards, as the flow increases, the diameter is increased. In this picture you can see this is a type of orifice. It is a variable orifice. Clear? So they are conical in shape. They are conical in shape. And these brown things, these small brownish red things, they are known as bobbins. They are known as bobbins, and these bobbins will indicate the flow, the number or the flow at which the gases are passing through the Dorsch tubes. So these bobbins, they are also known as float. They are also known as float or an indicator Clear? They are made up of aluminium. To keep them lightweight, they are made up of aluminium. The bobbins are of two types. They can be non-rotating. They can be non-rotating bobbins, or they can be rotating bobbins. Non-rotating or rotating. The rotating ones are known as rotameter. The rotating bobbins are present in rotameters. Now there are non-rotating types which are known as float, FLOAT, which are known as float. Clear? And here in this picture you can see a ball type a ball type of bobbin. Okay, here you can see a float in the other picture. Here you can see a float. How do you read the flow? How do you read the flow? If you have a ball type, then you have to read at the center. Here you have the readings on the glass. So whatever reading is corresponds to the center of the ball, you have to take that reading as a flow. If it is a float, then you have to take the upper rim. For the float, you have to take the upper rim of the bobbin. Clear? Now moving on. How are flow meters working? The flow meters work on the principle of Poiseuille's law. So according to this law, the flow rate across the tubes, if it is a laminar flow or it is a turbulent flow, it varies. The flow rate across the tube. What are the factors which are going to affect the flow rate? So at laminar flow or at low flows, the flow rate depends upon the viscosity of the gas. And a turbulent flow or high flows, the flow rate depends upon the density of the gas. Is this clear? Now let us see the arrangement, how these are arranged, how these flow meters are arranged. Always make sure that the oxygen flow meter is always present downstream to all other gases. Oxygen flow meter is present downstream. To other gases, to other gas flow meters. Why is this necessary? This arrangement will prevent any hypoxic mixture in case of any damage or leak. If there is a damage or leak in the gas, in the flow meters, then we have to make sure that oxygen has to be delivered for sure and not the nitrous oxide or air. We want 100% oxygen to be delivered in case of any damage or leak. So to prevent hypoxic mixture delivery in the event of damage or leak. Clear? Here in this picture you can see the oxygen is present downstream. Okay. And then we have something called as the auxiliary flow meter. You can see in this picture. We connect a Hudson mask to this auxiliary flow meter. Here you can see the connection of a Hudson mask to an auxiliary flow meter. This is just an additional flow meter. The machine need not be on for delivering this flow meter. Auxiliary flow meter. It is a self-contained flow meter. So basically it is a short tube which does not allow more than 15 liters of oxygen to be delivered. It is a short tube and it will allow a maximum flow of 10 liters per minute. So the maximum flow is 10 liters per minute and it can supply oxygen without turning on the machine, without the machine turned on. I hope this is clear. Now what are the hypoxia prevention safety devices available? hypoxia prevention safety devices in your anesthesia machine. Hypoxia prevention safety devices in your anesthesia machine. One thing is the mandatory minimum oxygen flow. Mandatory minimum oxygen flow, which is 50 to 250 ml per minute. Which is 50 to 250 ml per minute. Whenever the master switch is turned on, mandatorily minimum of 50 to 250 ml per minute of oxygen will flow before other gases will start flowing. Okay, this is called as mandatory minimum oxygen flow. Then we have something called as link 25 system. A link 25 system. The link 25 system is a mechanical linkage between the flow control knobs of oxygen and nitrous oxide. You can see in this picture, this is the nitrous oxide flow control knob, then the oxygen and nitrous oxide and oxygen flow control knobs. There is this mechanical linkage through this chain, or you can call them as sprockets. Okay, it is a mechanical linkage of flow control valves of oxygen and nitrous oxide. They will rotate at a ratio so that the minimum oxygen ratio will be maintained. Oxygen and nitrous oxide flow control valves will turn together. They won't turn independently, they turn together to maintain a minimum oxygen concentration of 25%. Minimum of 25% of oxygen will be delivered together to maintain a minimum of 25% oxygen. Minimum of 25% oxygen. This question can be asked in your examination. We are just not simply blabbering. These questions can be asked in your examination. So you have to stay focused. 50 to 250 ml per minute is the mandatory minimum oxygen flow, and 25% oxygen will be delivered by the link 25 system. Clear? Now let's move on. Coming to the last topic, we also have the pressure relief valves in the low pressure system. Again, we have the pressure relief valve. Before the common gas outlet, we have seen that there are pressure relief valve or the pop-off valve. Lastly, we have vaporizers. We will discuss about the inhalational agents later in the pharmacology of anesthesia, but briefly about the vaporizers. What does vaporizer do? A vaporizer stores and delivers inhalational anesthetic agents in a controlled manner. You can set up how much how much vapor or the gas you want to deliver. You can set up. It stores and delivers the inhalational agent in a controlled manner. Then the most important thing you have to know is the color coding of the vaporizers. So red is halothane. Okay. Then we have purple for isoflurane. Clear? Now we have yellow. Yellow is for sevoflurane. Then blue is for desflurane. So image will be given on the vaporizer like this, and they'll ask what vaporizer or which inhalational agent does this vaporizer deliver. So in this picture you can say yellow vaporizer, which will deliver sevoflurane. Then you have a purple vaporizer which will deliver isofluorine. If you have a blue one, it delivers desfluorine, and if you have a red one, it delivers halothane. There is a single point you need to know about desfluorine. Desfluorine is special. It requires a special vaporizer which is known as TEX6 vaporizer. Desfluorine requires TEX6 vaporizer. It is a special vaporizer. Why does desfluorine require a special vaporizer? 2 points. The first thing is it has a very low boiling point. It can boil even at room temperature. So low boiling point, 23 degrees, very low boiling point. Then it has a high vapor pressure. And also there is one more gas which is known as enfluorine. And the color coding is orange. We have seen the color coding orange for the cylinder cyclopropane, and now we have seen orange for enfluorine, but which was never asked in the exam. Remember isofluorine purple, sevofluorine yellow. This is most important. Then what metal is the vaporizers made up of? The vaporizers are made up of copper. Why copper? Because copper has a good thermal conductivity and specific heat. Because of good thermal conductivity as well as specific heat. Alright, so we have completed the video, and in the next video we are going to deal about breathing circuits. So you please subscribe to the YouTube channel and click the bell icon for getting the notifications on the next videos. And we have covered most of the anesthesia machine, and we have covered all the important topics where the questions can be asked in your MCQ examinations. And it is also a good brush up for MD anesthesia students or DNB anesthesia students. And do like the video if you have felt it useful. Then go to our Instagram page, the Anesthesia Notes, and click a follow in the Anesthesia Notes for daily updates. And also there is a Telegram link in the information given below. Click the link where you can get these slides posted in the Telegram page. Okay, all the best for your exam. Stay tuned for your next video.